All right, so the first number that we want to prove if it's prime or composite is the number 21. So does anybody have a guess as to whether they think 21 is prime or composite? What do you think, Elijah? Okay. Why do you think that? Okay, so I'm going to put this right here because that's your guess is that it's composite. Okay, so now we have to prove it. David, put that away. David, put that away. All right, so I'm going to go over here to our multiplication chart. Okay, and let's go ahead and look for the number 21 on our multiplication chart. Okay, so if I'm just scanning, and I just realized this is a 12 by or a 10 by 10, I could have done a 12 by 12, but that's okay. So I'm looking for 21, and there's a 21. Okay, so that gives me 7 times 3. Okay, I'm gonna look and see if I see 21 anywhere else, and I do not. So I'm gonna go back to my whiteboard, and I'm going to record what we just saw. So we saw that 21 had 7 times 3. Now, remember, 7 times 3 and 3 times 7 is the same thing. Okay, we don't write both of them. It doesn't matter which one you write, but we only write one. Okay, and if you think of the arrays, if I took those arrays in the videos and I moved them around, a 7 times 3 would look the same as a 3 times 7. Okay, so that's not a different factor pair. Elijah, question? I see, Jalen. Elijah, do you have a question? Absolutely, I was getting there. Okay, so remember, every single number has 1 times itself, right? Every number. It doesn't matter what number it is. 1 times itself is a factor pair. Okay, so since this has 2 factor pairs, this is a composite number. Okay, good job, Elijah. All right, so now let's think about the number 48. Do we think 48 is going to be a prime or a composite number? Jalen, what do you think? Is it going to be prime or composite? Why do you think prime? Okay, so I think what's happening there, you're actually mixing up those definitions. Okay, remember prime has only one factor pair. Okay, composite has two factor pairs. So do you want to change your answer? Composite. Okay. All right. So you think that's composite. Why do you think that's composite? Okay. All right. So we all automatically know that it's going to be 1 times 48, right? All right. So let's look at that multiplication chart. Do you see? Ooh, you know what? I'm realizing that maybe we need to change to this one. Okay. So do you see a 48? Yes. Do you not see the multiplication chart? No. Okay, so then I need to ask, are you seeing the whiteboard right now? Okay. So when I switch over here to this, are you seeing the multiplication chart? No. Okay. I think what I have to do, and this is going to be quite annoying, is to stop my share and go back each time. So now do you see it? Do you see the multiplication chart? Okay. Okay. All right. So take a second and look. Do you see 48s on that multiplication chart? Roger's shaking his head. Okay. All right. So I got to stop this share and go back to the whiteboard. All right. So tell me, what did you see for 48? 4 times 12. Excellent. Okay. Now, here's the thing. That's not the only way to get to 48. Okay. However, it might be the only way that we see on the multiplication chart. Okay. And the reason I say that is because isn't 48 an even number? Yes. Okay. So that means that I should be able to multiply 2 times something to get 48. Okay. Elijah, do you think you know what it is? 2 times. Okay, excellent. So 2 times 24. Okay. I also know because the divisibility rule for 3 says that if I add the digits of a number together and those digits are divisible by 3, the whole number is. Okay, what I mean by that is, what is 4 plus 8? 12. Is 12 divisible by 3? Meaning if I divide 12 by 3, do I have any remainders? Okay, Roger's holding up 4 fingers, so he's telling me 12 divided by 3 is 4, right? So are there remainders? No remainders, right? Okay, so if there's no remainders, then what I'm saying is 12 is divisible by 3. So if 12 is divisible by 3, then that means 48 is as well. Okay, so then that means 3 times something gives me 48. Okay, I know. And that's the divisibility rule for 3. We'll get into that a little bit more later. Okay, I know that 3 times 16 is 48. Okay, well, can I divide? Oh, I have my 4, right? 4 times 12. Is 48 divisible by 5? Meaning, if I divide it by 5, I have no leftovers. No, because in order to be divisible by 5, I have to have a 0 or a 5 on the end, right? Okay, so that wouldn't work. All right, so I have enough factors here. I have 4 factor pairs to prove that Jalen was correct, that it is a composite number. Okay. All right, let's do another one. 13. Okay. I know that 13 is one factor pair of 1 times 13. So now let me stop share this again. Okay. Now we're looking for 13. Do you see a 13 on there? Okay, so what does that tell us? What does that tell us if we don't see it then? Say it louder, Roger. Say it louder. You said it. 13 is what? Oh, you just said it. You said 13 is prime. Now, is it odd? Yes, it is odd. Absolutely. Okay. But it's prime because the only numbers, the only factor pairs is 1 times 13. Okay. There's there's no other way to make 13 with whole numbers. Okay. No, and I'm glad you brought that up. Okay. So let's talk about even numbers for a second. Okay. What does it mean when I say a number is even? What does that mean? I can divide it by 2. Yes, that is the definition of even, right? Okay. Well, so what's odd? What's that definition? No, no, but no, it is the opposite of even, but not multiply. It would be that you can't divide by 2. Okay. Remember, that's the definition of even and odd. Okay. Even numbers I can divide by 2 without a leftover. Okay. Odd numbers I can't divide by 2, or what I should say is I can divide by 2. Let me rephrase that. Okay. I can divide by 2, but with a remainder. Okay. So if I try to do 3 divided by 2, I can do that, right? I can do that, but then I have a remainder. Okay, so that's what that means, even and odd. So, as I said in the video, the number 2, okay, I know that the number 2 is even, absolutely, okay, but even and odd are not part of the prime and composite definitions. Look up here. Is there anything up here that talks about even and odd? No. Okay. Okay. Because this 2, what's the factor pairs for 2? What can I multiply together to get 2? Right? Otherwise, 1 times 2, same thing, right? Is there any other factor pair? Yes. Okay. So 2 is special because 2 is the only number that's even and it's prime. Okay? Because every other even number, 4, 6, 8, 10, 12, I mean, I can sit here and do the whole list out of even numbers, can all be divided by 2. Okay? So every other even number except for 2 is composite. Okay? It is a little bit weird. Okay, that's why I try not to, like, I really try to point out to you guys when we're doing prime and composite that it's really important to not always think of odd and even. Okay, don't think that every even number is composite and every odd number is prime because that's not true. Okay, think about the number 9. Okay, 9 is odd, right? If I tried to divide that by 2, I would have a remainder, so that's an odd number. Okay. Yes, absolutely. So the thing about that is for 9, 1 times 9 is a factor pair, but also 3 times 3 is a factor pair, right? Okay, so that's 2 factor pairs, right? Well, look at that. The definition says if it's got 2 or more factor pairs, it's composite, right? Absolutely. Absolutely. Okay. The number 20, oh, look, 21. We did that one already. We said that's composite. That's odd, right? Hey, there's a lot of odd numbers that are composite. Okay. Make sense? Okay. It's just background noise from Elijah. That's okay. No problem. All right. Are there any questions on prime and composite? Okay. All right. Elijah, I do need you to stay for just a minute. Let